So that was 10.7 complex numbers. All right, and then the one in your test is going to look something like the one we just did, where you are going to you will be taking the square root of a negative number, so that's where you get that I, and then you have to simplify the radical by finding a perfect square. So on 10.7, I told you on your study guide to look at numbers 9 through 14. Okay? 9 through 14. All right. But I need for you to go back and look at that video that's in that module 6.
So the eye always looks like that weird eye.
Yes, it looks like the italic eye. All right. Now, let me just mention this. If you have the cube root of a negative 8, cube root of a negative 8, is that going to be that I?
No.
No, because you can take the odd root of a negative number. You can't take the even root of a negative number. That's not a real number, so that's where that I comes in. The cube root of a negative 8 is what number? Not 2, negative 2. Negative 2. But the square root of a negative 8 is not negative. That's that I.
2i.
So, no, it's not.
No.
Square root of 8, 8's not a perfect square. So that's the square root of a negative 1 times the square root of 8. Square root of negative 1 is what? I. Now we got to figure out what the square root of 8 is. Simplified. What perfect square goes into 8?
4.
4. So that's the square root of 4 times the square root of 2, right?
Mm-hmm. And then the square root.
And the square root of 4 is
2.
2. So how do you write this answer, though? 2i. 2i square root of 2. Okay? So that's what you have to deal with on your test. Okay. All right, so that was 10.7. Then the other, I lost the study guide already. Let me see if this is it. Yeah. All right, so that's 10.7. So just make sure you can do this one. Now 11.1 part B. So take out 11.1 part B. Now go ahead and take out part A and B. 11.1 part A and B. Take out 11.1 part A and B. Okay, so on one of the worksheets that you had previously, the directions had said this. Directions said solve by factoring. All right, and then here was the problem. The problem was x squared minus 16 equals 0. That was the problem. What some of you did, a couple of you, the rest of you did it correctly. What some of you did was you brought the 16 to the other side. So you said x squared equals 16, right?
Mm-hmm.
And then you took the square root of both sides. That's what you did. Because the opposite of squaring is to do what?
Oh.
Square root. So you took the square root of both sides. But remember this. When I square a number, you can do this in your head. When I square a number and I want that to be positive, then what could x be here? What number squared 16?
Negative 4.
Negative 4 times negative 4 is 16,
4.
and also what?
Positive 4.
Positive 4. So when you take the square root of both sides, you have to say plus or minus. And so the square and the square root undo each other, so you're left with x, and you get plus or minus 4. All right? Now, a couple of you did that on that worksheet, and you didn't get any points because you didn't follow directions. Directions said to do what? Solve by factoring. So this is not factoring. This is using what's called the square root property. Square root property. Go ahead and write this down, square root property. So the square root property says that if I square an expression and it's equal to a number, then I can undo the squaring by taking the square root of both sides. So I'm going to talk a little bit more about that. If you had done this correctly using the directions, this is what you had to do. You have to factor this. That's the difference of two squares, right?
Mhm.
So you have to say, well, that's going to be x minus 4 times what?
Plus 4.
X plus 4 equals 0. And then you set each factor equals 0.
Out each side.
And so you had x to be a 4 and a what?
Negative.
Negative 4, which is what we got here. Okay? So this is factoring. This is square root property. So in your final, if it says solve by factoring and you don't use the correct, you don't follow directions, you're gonna be upset. You got to follow directions. So this is not factoring. This is actually using the square root property. So when you look at this worksheet part A, you look at worksheet part A, especially in 1 and 2, look at 1 and 2, how can you get x by itself?
Square root of
Take the square root of both sides. So you're going to use the square root property. So it says solve each equation by using the square root property. So when I have this example, let's say I had x squared equal a negative 64, let's say. You want to solve for x.
Mhm.
You want to solve for x. I have x squared right now. What's the opposite of squaring?
Square root.
Square rooting. Okay, now you got to remember what we just did though. When you take the square root of both sides, you got to remember you also have to write what symbols?
Plus or minus.
The plus or minus. And that's what students forget. So you got to say, well, that's going to be plus or minus the square root of negative 64.
Plus or
And so the square and the square root undo each other. So what do you write on the left, though? What does that become? X equal plus or minus. What's the square root of 64?
8.
8. What's the square root of that negative 1 become?
The I.
The I. So what's the answer? Plus or minus 8i. That's your answer. Okay? Plus or minus 8i. So 8i and a what? Negative 8i. Okay? Now, when you look at something like this example here, what if you had 6x squared equal, let's say, 18. 6x, oops, sorry. Let's see, 12 times 6 is what? What's 12 times 6?
72.
All right, let's say you had 72. 6x squared equals 72. Before you can take the square root, before you can use the square root property, let me just say this. Before you can use the square root property, it's got to look like this. It's got to be some expression squared equal a number. Some expression squared equal a number. And that coefficient right here must be a 1, right here. So if I look at this example right here, does this example look like this? No. Because I don't have some expression squared on the one side. What do I have on one side?
6x.
6x squared. So what's the first thing I've got to do?
Divide both sides by 6.
Divide both sides by 6. So I'm going to divide both sides by 6. Then I get x squared equal 12. Now I get x squared equal 12. And then now, what property do I then use? What's that property? The square root property. So you're going to say this now. Square root. But what else must I write? Plus or minus. Plus or minus. So whenever you take the even root, this only applies for even root. Now in here we only deal with square roots. But whenever you take the even root, you got to do the plus or minus. And we saw why a while ago when we did this. What number times itself is 16? Well, positive 4 and a negative 4. So you do that plus or minus. That's where that plus or minus comes in. So then, when I take the square root of x squared, what does that become? X equal plus or minus. How do I deal with the square root of 12?
You get the largest.
4.
No, 'cause
perfect
the largest
square
perfect
that
square
goes into 12. What perfect?
3.
3 is not a perfect
Or
square.
4.
4.
My bad. You're
So you're going to say the square root of 4 times 3. And what's the square root of 4?
2.
2,
So what's the answer?
2,
Plus or minus
2,
2
2.
square root of
3.
3. Plus or minus 2 square root of 3. Okay? And so if you look at that worksheet part A, if you go back to it, that's how you would do 3 and 4. Now, when you're doing 5 and 6, what do you think you'd have to do to get the square by itself? Come on, guys. You can't.
Oh, you gotta move the whole, you gotta
Yes,
move
you
the-
got it. Okay, so if you have this, if you have x squared plus 75 equals 0, you can't take the square root, you can't use the square root property just yet. It's got to look like something squared equal a number. That's not what you see. So what is it I've got to do?
Subtract both, 7 from both
Right, I've
sides.
got to subtract 75 from both sides. So I get x squared equal a negative 75. Now I can use the square root property.
Square root of both sides.
So when I use the square, when I take the square root of both sides, don't forget the plus or minus. What is the square root of x squared? X. Okay, now I'm taking the square root of a negative number, right? So that's at I. So I know I'm going to have plus or minus I. And then all I got to do, let me just rewrite like this. So you're going to have negative, square root of a negative 1, square root of 75, right? Square root of negative 1 is what? I. What perfect square goes into 75?
8,
8's not a perfect square.
25.
75, 25, right?
25.
25 times 3. What's the square root of 25?
5,
So how do I write the answer then?
X equals
Plus or minus
plus or minus 5.
5i
square root of
square root
3.
of 3. Okay? And so, huh?
I have to remember the plus and minus.
Yeah, that's easy to forget. And then when you do 7 and 8, then see how it's progressing? Each little part progresses. So in 5, you have to get x squared by itself by either adding or subtracting the constant. What do you have to do here first in 7 and 8?
Divide, we got to do
No.
both. You
Get
gotta
your number.
Get
to
the
right.
constant on the other side first, and then
Divide.
divide by the
Yeah.
coefficient. Okay? All right, so any questions on this? All right, I went through this quickly because there's a video I need for you to look at that goes with this. All right, but the one in your test does not come from here. It didn't come from here. The one in your test where you're going to use the square root properties on part B. It's on part B, but in order to be able to do part B, you have to understand part A. Okay? All right, so let's talk about part B. So suppose I had this now. Suppose I had x plus 1 squared equal 16. So I want to solve this equation. X plus 1 squared equals 16. And you want to use the square root property. So first of all, does this look like that form I need?
Yes.
Yes. So then what's the next step I've got to do?
Square root of both
Take the
sides.
square root of both sides. Now watch what happens. Very simple. Square root. Now on this side, what do I write though?
Plus or minus.
Plus or minus. The square and the square root undo each other. So what's left over here?
It's just x plus 1
X plus 1 equal
equals
plus or minus,
square root of 16,
which is
which is 4.
4. All right, so that's where I'm at. Okay? Any questions at this point?
No.
All right, now watch what you're going to do next. So
Subtract
notice-
1 from both sides.
not yet. Hold on. So x plus 1 equals two things. What do they equal?
Positive or
A
negative
positive 4 and a negative 4. So the best thing to do is to write this as two separate equations. So x plus 1 equals a what?
4,
4. And x plus 1 equals a
negative 4.
negative 4.
So x is equal to 3.
X is equal to 3.
negative 5.
And over here, x equal negative 5. So those are your solutions. 3 and a negative 5. Okay? So then if you had this, let's say you had 2x minus 5 squared equal, let's say, 36. 2x minus 5 squared equal 36. First of all, before I can use the square root property,
Flip down a little bit.
before I can use the square root property, I've got to make sure it's in that form where you have something squared equal a number. Do I have that here?
No.
Yes, I do.
Oh, because of the parentheses you do, yeah.
Okay, I do. So then I can go directly to using what property?
Square root.
Square root. So you take the square root of both sides,
2x minus 5 squared.
and when I take the square root of both sides, I'm going to put plus or minus
Plus or minus.
with the number.
So it cancels out
Yeah.
the 2x.
So the
2x minus
square
5.
and the square root undo each other, so you're left with
2x
minus 5 equal
plus or minus 6.
plus or minus 6. All right, now listen carefully. When I took the square root of this 16, and when I took the square root of 36, I got 6 here and then 4 over there, right?
Mhm.
Okay, so remember you learned in a previous course, and you also learned it when you were 2 years old, about rational and irrational numbers. You learned about rational and irrational numbers. So a rational number is any number that can be written as a fraction. Any number that can be written as a fraction where a and b are integers. But b cannot be 0, because if b is 0, it makes it undefined. You can't divide by 0. Okay? So I said integer. So for example, -8 divided by 7. Is that a rational number?
Yes.
Yes.
Yes, because -8 is an integer and 7 is an integer. -6 divided by -2. Is that a rational number?
Yes.
Yes.
Yes, because -6 is an integer and -2 is an integer. And in fact, I can simplify it and I get what number?
Positive 3.
Positive 3. The square root of 25 is a rational number, because the square root of 25, you know, is what number?
5.
5. And 5, I can write as a fraction. I can write a what
5 over
fraction?
1.
5 over 1. The square root of 6 is not a rational number.
No.
So if it's not rational, then it's what? Irrational. The square root of 6 is not a rational number, because I cannot write the square root of 6 as an integer divided by an integer.
Okay.
In fact, if you put square root of 6 in your calculator, go ahead and do that. Put square root of 6 in your calculator. Look at the digits. Do any of the digits repeat?
No.
No. There's no repetition at all.
Runs on forever.
It goes on for infinity, but there's no repetition. There's no repetition of digits. So that's an irrational number. So this is irrational right here.
Okay.
So 6.3333 repeating. 6.333 repeating. Is that number right here, 6.333 repeating? I'm going to ask you this question: is that rational or irrational?
Irrational.
Rational. 'cause
It's
the number's
rational.
Repeating, right?
Oh.
It's rational because 0.333 is what fraction?
3/10.
Oh, 3.
1/3.
1/3.
That's 1/3. So that's 6 and 1/3.
Okay.
And then 6 and 1/3 I can write as 19 over 3,
Right.
where 19 is an integer and 3 is an integer. So one of the things you learned also in terms of decimals is that if the decimal repeats, if the decimal does not terminate but it repeats, then it's a rational number. You can always write it as a integer divided by an integer. So so this is rational. If you had something like this, -7.238401 0.26 dot dot dot,
Irrational.
that's irrational. It doesn't terminate, but there's no repetition of digits. So that's an irrational number. If you have this, negative 7.2864, negative 7.2864, is that rational or irrational?
Rational.
It's rational because it terminates. Any decimal that terminates can always be written as a fraction where you have an integer over an integer. So this is rational because it terminates. All right, now let's go back to this. Is 6 a rational or irrational number?
Irrational.
Rational.
Rational.
Okay.
It's rational. So if it's rational, so when I take the square root of both sides and I get this right here to be rational, then you want to split it apart. That's how you want to do it. You want to split it apart.
2x.
So you're going to say 2x minus 5 equals what?
6.
6, and then 2x minus 5 equals
negative 6.
-6. So that means you can write your answer, your solutions as rational numbers. So those are rational.
So add 5 to both sides.
So add 5 to both sides, I got 2x equal
11.
11, so what's x? 11 over 2. So that's one of your solutions. So it's rational, right?
Yes.
Over here, when I add 5 to both sides,
Yeah, -1.
I get 2x equal -1, so what's x? Negative 1/2?
1 over negative 1 over 2. Negative 1 over 2.
All right, so those are your solutions. All right, now what if you had this? Suppose I had 3x plus 1 squared equal 18. 3x plus 1 squared equal 18. So first of all, can I use the square root property?
Yes.
Yes. So I take the square root of both sides.
Plus or minus.
Plus or minus. So the square and the square root don't do each other. So what's left on the left?
3x plus 1.
All right, now let's talk about the square root of 18. How is that different from the other two? Because 18 is not a perfect square. So since 18 is not a perfect square, is this going to be rational or irrational? Is my solution going to be rational or irrational?
Irrational.
It's going to be irrational. But I still got to simplify the square root of 18. So let's think about what the square root of 18 is.
9.
That's 9 times 2, right?
Right.
So what do I get?
Square root of 3.
3
3.
square root of
3
2.
square root of 2.
So that's plus or minus 3 square root of 2. All right, now listen. Now it's in that video, so you may need to go back and look at those videos. So it's rational. I get the solutions that look like this, correct?
Mhm.
Okay. This is irrational. So the way you want to write it is this way. The way you want to write it is this way. You're gonna leave it as plus or minus. So you're gonna subtract 1, and so I get 3x equals -1 plus or minus 3 square root of 2. All right.
Still divide both.
And then I divide both sides by 3.
Just put everything over 3.
Yeah, so I get x equals -1 plus or minus 3 square root of 2 all over 3. So that's how you're going to write the answer, your solutions. That's how you're going to write your solutions. Now, let me go back to this right here and kind of show you the similarity between these two. So watch. It's not difficult. Just watch. So watch. You remember right here where we had 2x minus 5 equal plus or minus 6?
Mm-hmm.
All right. So I'm going to make it look like this right here. Make it look like this. So 2x minus 5 equals plus or minus 6. So I'm going to bring the 5 over. So I'm going to add 5 to both sides, right?
Right.
So I get 2x equals 5 plus or minus 6.
Yeah.
Then divide both sides by what? 2. So I get 5 plus or minus 6 over 2. See, it looks like this, right?
Right.
Okay. But this is what kind of solution? Rational, irrational?
Irrational. Well, it's rational.
Rational. Those are all rational numbers. So that's rational. So if it's rational, I want you to rewrite it to make it look like two rational solutions. So you're going to say 5 plus 6 over 2, and then 5 what? Minus 6 over 2. And what's 5 plus 6?
11.
11 halves. And then what's 5 minus 6?
-1.
Negative 1 halves. So you see, it doesn't matter what approach you take. You can do it this way, You can split it apart right away, or you can make it look like what we did here and then split it apart. Okay? But listen carefully. So you see that these two is in the same form, correct? Except this is what kind of solutions? And this is what kind of solutions?
Irrational.
Irrational. So if it's irrational, leave the answer like this. If it's rational, I need for you to tell me what those two rational numbers are. Now, I want to say something. When you do my math lab, though, when you do my math lab, they're going to want this separated. And here's what I mean by that. You're going to say -1 plus 3 square root of 2 over 3. And then what's the other? -1 minus 3 square root of 2 over 3. So that's how it's going to look on my math lab. You can't leave it like this on my math lab. And on the worksheet and on the test, you can write it like this, but in my math lab, you got to separate it. You have to separate it. Okay? All right, so what if you had this? Let's say you had 3x plus 7 squared equal negative 16. So 3x plus 7 squared equal negative 16. Square root of both sides, right? Square root, what do I need to put? Plus or minus. These undo each other, so what's left?
3x plus 7
Equal plus or minus
4i.
4i. Okay? Now remember, the only time you're gonna write it like this is if these are what kind of numbers? Rational. An I is not a rational number, so you're gonna write it just like we did this one. All right. So yeah, so you gotta get x by itself though. So you get subtract 7. So how are you gonna write this? 3x equal what?
3x equals -7 plus or minus 4i.
Okay. And then finally divide by what?
Divide by 3.
3.
X equals all that other stuff.
So -7 plus or minus 4i all over 3. On my math lab,
You gotta do x equals -7 plus 4i over 3 and -7 minus 4i over 3.
that's all you do. Okay, on my math lab, that's what it's going to write it as. But the point is, you have to know how to write your solutions based on what numbers you're dealing with. If it's rational, irrational, or complex. Okay? All right. Now, if you look at your worksheet, go ahead and take this out. Take this out, 11.1 part B. Y'all can do 1 and 2 very easily, right? Okay. You can do 3 and 4 easily as well. 3, you have to simplify because 24 is not a perfect square.
Right.
64 is a perfect square, so that's where you're going to get rational solutions, right? You understand what I'm saying? Rational solutions here. These are complex. This is going to be complex. This is going to be rational. Turn the back. Number 6. Is number 6 going to be rational or irrational solutions? Number 6.
Rational.
32.
Oh,
Irrational. So remember how to write the irrational. -25 is an imaginary number. So that's an I. And -48 is that imaginary number, but you have to simplify. What perfect square goes into 48?
8. Wait,
8's not a perfect square.
Sorry.
4 is not the largest, though.
16.
16. 12 is not a perfect square. 16.
Times 3 is
16 times 3 is 48. All right, you understand how to do this. So on your test, you have one like this. No, I'm sorry. What does it say?
Yeah, there's a bunch of them actually. There's one like
Yeah, so that's 2 of them.
one like 1, 4, and 6, and one
Yes,
like 2.
so make sure you can do this because you're talking about 16 points right here. It's doable. It's not difficult. You can do this. So what I need for you to do, listen carefully. I need this worksheet turned in Tuesday. You understand? Because I need to give you the key to this, because that's on your test.
I thought you wanted all of it for Tuesday.
All right, so 11.1 Part B is due when? Tuesday. All right, so that takes care of... Okay, on that study guide, I keep losing that study guide. On that study guide right here. So on the study guide, you can now do 11.1B, right?
Right.
Okay. Just go back over the video. Look at the video that's in Module 6. Look at the video that's here. And then look at those notes. All right, but you don't lose points here because you need that B on this test, some of you. All right, now let's talk about 11.2. So right now you know the 11.1. First of all, you know that 10.7. Let me do this here. Put due Tuesday. Due Tuesday on the study guide. 10.7 is due Tuesday. 11.1 is due. 11.1 Part B is due Tuesday. And 11.2 Part A is due Tuesday as well.
You're going to put it all on Canvas, I'm sure.
It's already on Canvas. It's on Canvas. Okay, now, so the good thing about the one that's on your test, now in your final, it's going to be a little bit, we're not covering everything today dealing with quadratic formula, but the one that's on your test will be rational solutions for the quadratic formula. So if I wanted to solve this equation, and this is 11.2, solve quadratic equations. Solve quadratic equations. So let's suppose I had this. All right, suppose I had 2x squared plus 5x minus 3 equals 0. All right, so suppose this was a problem. How would you solve this quadratic equation? Okay, factor. Now, here's the thing, though. Can every polynomial be factored? No. All right. So remember, there was times when it wasn't factored, you wrote the word prime.
Mm-hmm.
So there are some situations now where you're going to get a quadratic equation. We're talking about quadratic this time. So in this section, we're talking about quadratic. So these are quadratic equations, but not all quadratic equations are factorable. So then you got to find another method of solving this quadratic equation. Now this one is factorable. So it is factorable. So if you want to factor this one, now on your final, this is probably usually this is what they ask you to do. It says solve this quadratic equation by factoring,
Mm-hmm.
or it could say solve this quadratic equation using the quadratic formula. All right. So if it says use quadratic formula, probably because it's not factorable. But this one is factorable. So how can you factor this?
2x and x.
2x and x. 3 and 1. I think the 3 is going to go here, and the 1's going to go there. Nope. Nope. The 1 goes here, the 3 goes here. Right?
Mm-hmm.
All right. Last sign's negative. These signs are different. I want the larger to be positive. So that means that this is the positive one and this is the negative one. All right. So it's factored correctly then. What's the next step you took? What's that property called? Zero factor property. So you said each factor equal to 0.
Separately.
So 2x minus 1 equals 0. X plus 3 equals 0. So here 2x. So I went from a quadratic equation to linear.
Okay.
So 2x equal 1. So what's x?
1/2.
1/2. Here x equal negative 3. So what I want you to notice, though, is that when you have a quadratic equation that's factorable, your solutions are rational.
Okay.
See how these are rational? It's always going to be that way. So whenever it's factorable, that means your solutions are rational. Now, I want to do the same problem. So this was done by factoring. I want to do the same problem, but this time use the quadratic formula. The derivation of the quadratic formula involves something you haven't done here. And you won't do it until next semester, and that's called completing the square. But you're not going to deal with that until next semester. So we can't derive the quadratic formula. You can't see where that quadratic formula comes from because you don't know how to complete the square. So I'm going to give you the quadratic formula in your test. So here's the quadratic formula. So given any quadratic equation, ax squared plus bx plus c equals 0, and notice, though, that this has to be written in standard form. Remember, standard form means that what's on the other side? 0. So to solve this quadratic equation, in standard form using the quadratic formula, and I'm going to use the quadratic formula with this one, your solutions will be, and here's your formula, the opposite of b plus or minus, remember this, when you take the square root of both sides, you get the plus or minus, so that's where that plus or minus comes in. So if you had actually done the derivation using completing the square, at some point you would have had to take the square root of both sides. And so that's where that plus or minus is coming from. So plus or minus the square root of b squared minus 4ac all over. So this whole expression right here is being divided by 2a. That's the quadratic formula.
Crap.
So the opposite of b plus or minus the square root of, and the radicand is b squared minus 4ac. That whole expression is being divided by 2a. Next semester, you're going to learn that this radicand right here is called the discriminant. And the discriminant distinguishes between whether your solutions are rational or irrational and how many there are. So that'll be next semester. But all you got to do in here is just know how to plug numbers into this. All right, so you don't have to memorize that formula. I'll give it to you. You just need to know how to use it. So the A, B, and C that you have to plug numbers into, the A is a coefficient of x squared. The B is a coefficient of x, and C is your constant. So in our problem here, first of all, is this in standard form?
Yes.
Yes. So what is A in this case?
2.
2. So say A equals 2. A equals 2. What's B in this case? 5.
Well,
And
we
what's-
can't see it anymore.
Well, if you wrote it down, you'd be able to see it.
But you wrote it
C
down,
equals
so-
-3.
And what's C in this case?
-3.
-3. Now be careful. If this was -5x, if that was -5x, then B would be what?
-5.
-5. Okay, good. So C is what?
-3.
-3. And all you do now is just plug and chug. So here we go. X equals, now listen to my words, the opposite of B. So if B is a 5,
-5.
this is -5. Plus or minus the square root of B, and always put B in parentheses because sometimes B is negative. So put in parentheses. Always put B in parentheses. If you don't put B in parentheses, then it's negative, and use your calculator is going to give you a wrong answer.
So -5.
No, not
No.
negative. I mean positive 5
Positive
squared
5
because
squared.
B is yeah, under the square root.
Right.
Oh, okay.
So B is 5. Put that 5 in parentheses.
And
In fact, under the square root, you can put all these in parentheses. -4 times in parentheses A. What's A?
2
Times C in parentheses, which is
-3.
-3. All
That
over 2 times A,
2.
which is 2 times 2. All right, so make sure you see what I wrote. Hold on, David. Make sure you see what I wrote. All right, so -5 plus or minus the square root of, and those the radicand, I put all those substitutions in parentheses. Now the next step is to simplify your radicand. Next step is to simplify the radicand. So what is that 5 squared?
25.
25. So that's what you would deal with. So you're going to say -5 plus or minus the square root of 25. All right, now, remember, this right here is really a -4. So a negative times a positive times a negative is a what? Positive. So it's going to be 25 plus. 25 plus.
Okay.
Now, what is 4 times 2 times 3?
24.
24? Okay.
Yes.
So you get 25 plus 24, correct?
Yep.
All over, and then what's 2 times 2?
4.
Now go back and simplify the radicand more. What's 25 plus 24?
49.
Okay, so I get -5 plus or minus the square root of 49 all over 4. So that's where I'm at. That's where I'm at.
-5
Hold
plus
on,
or
hold on.
minus 7 divided by...
Okay, now the one in your test, when the one that's coming up, now the one in your final could be irrational, but the one in your test can be rational. That means that that square root of that radicand is going to be what kind of number?
Rational.
Perfect square.
First square.
What's the square root of 49?
7.
7.
So now you're going to write it like this. You're going to say -5 plus or minus 7 over 4. And then you split it apart. Then you split it apart. So you get -5 plus 7 over 4. And then what?
-5 minus 7 over 4.
And what's -5 plus 7?
2.
2.
And what's 2/4?
1/2.
And then we get 1/2 earlier?
Yep.
What's -5 minus 7?
-12.
Over 4, which is what?
-3.
So there's your solutions. Now, it was easier to do that by factoring, right?
Oh, yeah.
You see how much easier it was? But now you know how to use a quadratic formula. Now let me say this. Can all quadratic equations be factored?
No.
No. You have to then resort to what? Quadratic formula. Can all quadratic equations be done using quadratic formula?
I'm assuming
Yes. Yes. All right. So what happens is that if some students they have a quadratic equation and they're struggling trying to factor it, if you're struggling trying to factor it, probably it's because it cannot be factored. So then you would do what? Quadratic formula. Okay? All right, let's do another one that's rational. So let's do another one. So let's suppose you had this. All right, suppose you had this. Suppose you had all right, solve. 10x squared minus 19, that's 10x squared minus 19x equal a -6. So 10x squared, that's 10x squared,
Not
minus
10 form.
19x equal -6.
You gotta add 6 both sides.
So you, first of all, before you even factor or even before you use quadratic formula, it's got to be written in what form?
Standard form.
Standard form. So I got to bring that -6 over
10x squared minus 19.
and put in descending order.
Equals 0.
All right, now we're using a quadratic formula, okay? So tell me what A is.
10.
10. What is B?
-19.
Very good. What is C?
6.
All right, so I found A, B, and C. And all you do is plug those numbers into the corresponding variables.
We're going to have to be able
But-
to see the formula.
But, right, I'll give you the formula. But here's the formula. So X equal the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. All right, so here we go. So X equal
Goes the opposite.
the opposite of B. What's B in this case?
-19.
So what's the opposite of -19?
19.
19, okay? So you can say 19. Is that clear?
Yes.
Listen to those words. Plus or minus the square root of, now the radicand, the discriminant, B squared minus 4AC is called the discriminant, but let's just refer to it as a radicand. The radicand, you're going to put all those numbers that you're substituting in parentheses. So I'm going to say parentheses B, and what's B?
-19.
And what am I doing to it?
Square.
Squaring it. Minus
Minus
4
4
times A in parentheses
10,
times C in parentheses.
6,
All right. All over 2 times A in parentheses, which is 10, right? Now, he said he said, I'm just going to put it as 20. You could put it as 20. You don't have to say 2 times 10. You understand? You agree?
Yes.
Okay. Now, you got to simplify that radicand, though. Now, there's no way I expect you to know what negative 19 squared is, so use your calculator. What's the negative 19 times the negative 19?
361.
Okay, so before I go on, should b squared, is this right here ever going to be negative?
No.
No, because you're squaring it, right?
Mm-hmm.
So either it's going to be a 0 or it's going to be what kind of number?
Positive.
Positive. So that's what I'm saying. Make sure you put those in parentheses, because if you didn't, and you put negative 19 squared in your calculator, you would have got a negative number. And I've seen students actually leave it as negative. But it's got to be what kind of number here? 0 or what?
Positive.
Positive. All right. So we get this now. We get 19 plus or minus the square root of.
361.
Okay, now here's how we deal with this product right here. What's a negative times a positive times a positive?
Be a negative 40
Negative.
times 6.
4 times 10 is 40. What's 40 times 6? 240?
Yeah, 240.
240? All over
20.
20. And then tell me what 361 minus 240 is.
361 minus 240 equals 121.
Okay, now before we go on, any question at this point?
No.
So all it is just plugging numbers back into the formula.
Then you got to
Okay, hold on. Then you plug in numbers into the formula. So you'll get points along the way. You'll get points along the way. All right, now you gotta remember, at this point you gotta ask yourself, all right, now I'm at that point here. Am I gonna end up with rational or irrational solutions? What's the answer? Huh? Rational.
Rational is
Because
11.
121 is a perfect square.
That's 11.
And in fact, if you did not know it's a perfect square, then on your calculator, all you do is this. Take the square root of 121.
See what it
If
is?
it's a whole number,
It is rational.
it's rational. If it's a decimal, it is irrational.
Okay, that's 11.
All right? So it's 11. Square root of 121 is 11.
19.
So you're going to say 19 plus or minus 11 over 20.
And then you got to split it.
And then that's where you split because it's rational. So you're going to say 19 plus 11 over 20. 19 minus 11 over 20.
That's
So that's 30 over 20, which is 3/2. Okay. This is 8 over 20, which is 2/4. No, 2/5. 2/5. They're both divisible by 4. Okay. Any questions? So that's what your test going. That's the one on your test. It'll look just like this. So it'll be rational. So just know how to plug and chug. Write your answers as rational. You're done. Now the one your final could be irrational. Or it could be imaginary. So we're gonna look at one like that also. Okay. So on your study guide, on that study guide, go and take that study guide out.
That was 11.2, part A.
All right. So 11.2, part A. So you are going to have to use quadratic formula. So when you take 11.2 part A out, go ahead and take that out. 11.2 part A.
But not B.
Okay, find your 11.2 part A. Okay. So don't forget there's some problems in the back. So there's 6 of them altogether. So all of them solve each equation using quadratic formula. Show all work is presented in class. Videos receive full credit. So all of these, I think, because that was a part A. All of these are rational solutions.
Okay.
So you can use quadratic formula. All right, now, but you got to remember, though, that it's got to be in what form? Standard form.
form.
Now, you know how I was saying x equal?
Mm-hmm.
All right. See how your variable is y? So you're not going to say x equal, you're going to say what?
Y equals.
Y equals. Okay. So any questions? All right, so I need this Tuesday, okay? Because it's on your test. This is Tuesday. All right, so any question at this point? All right, so I went through this quickly. So in your study guide, that takes care of this new stuff right here.
In order for us to do that worksheet, we'd have to have the formula. Are you gonna have the class notes up soon enough that we were able to get the formula off of it? Or do we need to write the formula down now?
Write the formula down now, but it's in the video.
Oh, it's in the video, okay.
Yeah, you just gotta watch the video, but you may want to write the formula down if you're not gonna look at the video. Okay, now listen carefully to this next one. Okay, so you should be able to do all these now. This is very easy to get. Don't forget the back part. So it's very easy to get at least a B on this. Now remember where some of you are messing up is on those graphs. So make you see where it says. Oh, okay, I got to do this one. All right, so the functions, you have functions in there again. You have the graph. So your graph will either be quadratic or it will be absolute value. Now turn the back of that study guide. Turn the back of the study guide. You remember we graphed some lines at the beginning of the semester?
Vaguely,
And we did it using a T-table.
yeah.
Last semester when you graphed lines, now in here, we only spent a few minutes on graphing lines. But last semester you spent a whole chapter on graphing lines. Last semester's final, though, had a problem where you had to graph a line using intercepts. I didn't give you a worksheet at all on intercepts. Although you did it last semester, you didn't do it at all in here. So that was on your final a problem where you had to graph a line using intercepts. So I need to put one in your test. It's easy.
X and Y.
So yeah, just X and Y intercept. So write this example. So that's going to take care of this one right here. So graph a line using intercepts. And the only reason I'm putting on the test because on the final last semester. So they may not have it on the final. I don't know. But just in case. All right, it's going to look like this. So it's a very simple one. So let's say you want to graph 2x minus 6y equal 12 by graphing the intercepts, using intercepts. Okay, using intercepts. Now, you're also going to be asked to write the intercepts as an ordered pair. Now, ordered pair means x and y. 2 points, x and y. Okay, so remember we talked about intercepts last semester. So intercepts means this. Let's talk about the x-intercept. The x-intercept is where the graph crosses the x-axis. Well, wherever the graph crosses the x-axis, what is the y-coordinate?
0.
0. So you learned last semester that to find the x-intercept, you let y equals 0. That's what you learned. The y-intercept, that's where the graph crosses the y-axis. No matter where I am on the y-axis, what is the x-coordinate? 0. So you learned last semester that to find the y-intercept, you're going to let x equals 0. Okay? And watch how simple this becomes now. Okay. So let's find the x-intercept.
6.
To find the x-intercept, you let what?
Y equals
Y
6.
equals 0. So when y equals 0, what happens to the 6y term?
It goes away.
Yeah, it's 0, because 6 times 0, or negative 6 times 0 is 0. So basically what you can do is just cover up this term, and you're left with what equation?
2x equals 12, divide by 2 on both sides, x equals 6.
So there's your x-intercept. That's your x-intercept. That's where the graph's going to cross the x-axis. But it's going to ask you to write as an ordered pair. So as an ordered pair,
6 comma 0.
6 comma 0. Because remember, to find the x-intercept, y had to be what?
0.
And so what's x?
6.
6. That's your ordered pair.
One of your points.
Right, that's one of your points. Now, to find the y-intercept,
You gotta let X equal 0.
To find the y-intercept, you let x equal 0. So basically cover the x term. Cover the x term. What equation is left though?
Negative 6.
Negative
times
6y.
y
Not
equals
6y, but a what? Negative 6y
Y equals
Y
negative 2.
equals,
equals 12.
yeah,
So what's y?
y equals
Negative
negative
2.
2.
That's your y-intercept. So as an ordered pair, what do you write though?
0, comma, negative 2.
And then you graph it.
There's your 2 points to plot.
You graph it. So 6, 0, remember to plot a point, you start the origin.
Yeah.
So you go 6 units to the right, and then you stop because y is what? 0. So there's your x-intercept. So that's the point 6, 0. The y-intercept, 0, negative 2, is located where?
On the x, I mean, on the y-axis, so
Below or above?
below,
Below.
so negative 2.
Yeah.
And then draw your line.
So that's 0, negative 2, and then you draw your line with the arrows. So I went through this quick, but on your test, you're going to have one where you have to use the intercepts, x and y intercepts. There's not a video on this, so you okay with this?
Yeah.
Okay, to find the x-intercept, you let y equals 0. To find the y-intercept, you let x equals 0. Okay, it's very simple. And easy 8 points to get.
We need lots of those.
Oh, you had it on,
This class, we had it.
where you find the intercepts?
Yeah.
Oh, okay.
There was one of those on test 1, I'm pretty sure.
Oh, okay. All right. I thought it was just using a t-table.
Mm-mm.
Okay. All right. Okay. All right. So now let's see. Yep. Okay. So Tuesday we're going to talk some more about the quadratic formula. Now, the one of your tests is only going to be rational, so it will look like we just did. But remember, are all quadratic equations factorable?
No.
Now, when we did those two using quadratic formulas, rational, right? That means that you could have done it by factoring. But are all quadratic equations factorable?
No.
No. So we have to do one Tuesday where you get irrational or where you get imaginary. Because that's going to be important next semester as well. So we do that Tuesday, but that's not going to be on your test. So your test, this is it. Just with the study guide. Okay, now